Okay, so like I was saying, it's not square root, it's fourth root. Okay, so when it's square root and we do a factor tree and everything, we're looking for pairs, right? But when it's fourth root, we're looking for groups of four. So when I do my factor tree, I'm going to do 16 times 3, and then 4 times 4, and then 2 times 2. But it doesn't matter. Some of you went 12 times 4, maybe 2 times 24, maybe 8 times 6. Doesn't matter how you start. Just do your factor tree. And right here, I have a group of 4 2's, right? That means I can pull a 2 out front of the radical. All right? The 3 is going to stay underneath the radical sign. Okay? So over here, I'm going to pull a 2 out. All right? But in my fourth root part, there's still a 3 there. You with me on the numbers on that 48?
Yes.
Okay. Now, x to the fourth means that, right?
Yeah.
So how many groups of 4 in the x's are there?
There's 4.
Well, there's one group of 4, right?
Yeah.
So I can pull 1x out. Or you can just divide 4 by 4, right? Which is 1x, right? For the y's, there's 8 of them, right? So how many groups of 4 y's are there? 2, so what do I pull out? 2 y's, y times y, which is y squared, right? And there's no x's or y's left over to put underneath. You guys understand that, right? William, focus. All right, now z, okay, there's 11 of them, right? But there's still 2 groups of 4, and then there's 3 left over, right? So this time the z's are left over also. So I can pull 2 z's out, which is z squared, but there's still 3 z's left underneath. So there's our answer. Okay, you understand that? You don't have to write them all out like I did. You can go 4 divided by 4, so there's 1x. 8 divided by 4, so there's 2 y's. 11 divided by 4 is 2 with 3 left over, right? If you do that, okay? So I don't, if you want to just divide it instead of write them all out, that's okay too. All right, we good for number 11? Okay. Number 12. We have f of x is 9x cubed plus 2x minus 1, and g of x is negative x cubed minus x squared plus 5x minus 8. All right, so we have those 2 functions, and we're supposed to figure out this problem. If I could get it to not make a mess here. F minus g of 2, right? That's what we're trying to do. Now, there's 2 ways you can do this. I've talked to you guys, some of you already. You can subtract the 2 functions first, and then plug 2 in for x to find the answer. What I like to do is plug 2 in for x first, then subtract. Either way works, though. Okay? So I do f of 2 and g of 2. So wherever there's an x, I put a 2. I'm going to figure out that answer. Then I'm going to go g of 2. And wherever I see an X, I'm gonna put a 2. And figure out that answer, then once I get the 2 answers, I'm gonna do that subtraction, that F minus G, okay? So 2 cubed is 8, times 9 is 72, 2 squared is 4, or 2 times 2 is 4. So 76 minus 1 is 75. 2 cubed is 8, but negative 8. 2 squared is 4, but negative 4. 5 times 2 is 10, and then minus 8. So negative 8 minus 4 is negative 12, plus 10 is negative 2, minus 8 is negative 10, right? So remember, what am I supposed to do with those 2 answers? Subtract them, right?
Yeah.
That's what we're supposed to do, subtract them, right? Why didn't that go blue like I wanted? All right? So minus a negative is positive, so the answer is 85. Make sense?
Yeah.
That's how I would do it. But again, if you want to subtract the g function from the f function first, and then plug your 2 in, you'll get the same 85. Okay? All right. Number 13. Here's another function problem. F of x is 2x. G of x is x to the 5/7. And we're supposed to do fg of x. What's fg mean? Multiply, right? If there's no, that's different than number 8 that we did yesterday. Okay? 8 was this. That's a composition of functions. That's when we put the g function in place of x for the f function. That was number 8, what we did yesterday. Okay? This just means to multiply the 2 functions, what we're doing now. Okay? So just wanted to show you that the difference between the 2. Okay? So all we're doing is 2x times x to the 5/7. All right? So what do I do with those, that x and that x to the 5/7? How do I multiply this? Yeah, x is 7/7, right? It's 1, right? We're supposed to do with those exponents. What am I supposed to do that 7/7 and 5/7? Add them, right? That's the rule, right, for exponents? Just add the exponents when you're multiplying 2 numbers with the same base, or 2 terms. So that's a 12/7. Okay? That's all. Simple, right? If you want to write it as 1 and 5/7, you know, because you know that's a 1 there, that's fine too. That's acceptable. But usually we write it as an improper fraction. Okay, number 14, the last one from chapter 5, is we're finding the inverse of this function. So remember, the symbol for inverse just means that, right? That little -1 exponent. Well, what did we do when we did these? Do you guys remember?
No.
Nobody remembers? Not one person. No?
We have stupid, but isn't it just 3x plus 30?
No, not quite.
Not yet.
Okay? So we think about this as y equals 3x plus minus 30. Right? And when we did the inverse, what did we do with the x and the y? We just switched them.
Yeah. Switch it.
So we do this as x equals 3y minus 30, and then get y by itself.
Yeah.
And that will be the inverse, okay? So whatever, function I use, think of that as y equals and then switch them. Okay, it could be f, g, doesn't matter. All right, so I'm gonna add 30 first to get y by itself.
Ah, dude, that's so.
Usually so.
So x plus 30 is just that, x plus 30. They're not like terms, right? All right, and then what do I do to get y alone?
Yeah.
Divide by 3. So you can leave it like that if you want. Okay, this is okay. Now I don't know if this is on the, the multiple choice part or the part where you just free response where you have to write it out. Okay? But maybe if it's multiple choice, it would be written this way. What's in front of that x? 1. So it's probably written like this if it's in your multiple choice.
All of it?
So it'd be 1/3 x plus 10 also. So remember, the first 10 on the exam is free response, like we're doing the whole practice quiz for exam, all right? But actually, there's only 10 that are free response, and the last 20 are multiple choice, okay? So I'm not sure where this one fell, if it was one or the other. Okay. The exam's not exactly like we've done, because I picked different problems from each chapter to put in the first 10 for free response. And then I threw in the other type so it's not gonna be like the first 10 that you see on the practice are the free response ones. You understand what I'm saying? Okay, so it's a little bit different than what you're used to, because everything else we've done has been exactly the same, right? The practice and the quizzes or tests have been exactly the same. Just changing up the numbers, but exam's a little bit different because I put some multiple choice and pre-response. I kind of switched them up. So 15 is the start of chapter 6 stuff, which is our logarithm chapter. All right, so first one is we're solving this logarithmic equation. And when you have a logarithmic equation and you want to solve it, you got to turn 2 logs into a single log. You have to condense it. So how do we condense those 2 logs? We turn it from addition into, multiplication, remember? So this problem becomes log of x times x plus 48. So our rules of logarithms states that I can turn 2 or condense 2 when it's addition into multiplication. What if that was subtraction? What would I have done with those? I would have changed it to a division problem or a fraction, right? Now, what's my base for my log? We just haven't written it. If you don't see a number there, what's the base? 10. Very good.
Yes.
Okay, so remember, that's a base 10 log for this problem. So what we did at this point, we turned it into an exponential problem, okay? So what we did was, what was it? B, here was a little formula we learned. That's the exponential. The log was log base B of A equals X. That's where the things went. All right, so we're here. Log base 10 of X times X plus 48 equals 2. This is going to be in logarithmic form. Exponential form, the the A, which is this, right, equals the base to the x power. So base is 10 to the second power. So that's the problem we're solving. Okay? So you might want to put this red thing here I just wrote on your note card to remind you how to change it from one form to the other. Okay? So to solve this problem, what do I got to do with that x on the left? First, what do we call this? Distribute, right? And what's 10 squared?
100.
100. So it has turned into a quadratic equation. That means I got to move the 100 over and set it equal to what? 0, right? Quadratic equations, we've solved a lot of those. We have to set them equal to 0. So when I move the 100 over, I'm going to subtract it over, right? When you go to the opposite side, you do the opposite. So a positive 100 becomes a negative 100 when I move it, right? Subtracting it. So what are the factors of negative 100 that add up to positive 48? 2 and 50, right? X minus 2 and x plus 50 is how that would factor. Negative 2 times positive 50 is negative 100. And negative 2 plus positive 50, or just plus 50, is positive 48, right? So what are my two answers? 2 and negative 50. Now, when we did log problems, log equations like this, we had to check our original problem to make sure we weren't taking the log of a negative number, okay? Because we can't do that. So if I go back to the original, I put negative 50 there, what's happening? Log of negative 50. Am I allowed to do that? No. So is negative 50 a good answer? No. Well, I wanted to mark that off. Okay, so the only correct answer is 2. Okay, now if that's a multiple choice problem, you could plug your choices in to see which one works, right? You know, if you're not sure what to do, and if you have choices and it's an equation you're solving, you could just plug in your choices until you find the one that works, right? Make sense? Hey, Jay.
Will we get full credit for that? Or we have to show this?
Nope. On the multiple choice, I don't give you any credit but right or wrong. Okay?
So sweet. Freaking sweet.
So the free response ones, I'll give you some partial credit for showing some work, and if you are doing part of it right, I'll give you some partial credit. But on the multiple choices, it's going to be right or wrong, okay? All right. Any other questions on number 15? So again, we condensed it to a single log. If there's no log base, the base is 10. That's the one in our calculator. Rewrite it as an exponential and then solve it. All right, number 16. Let's go to the next page. Give us some more room. Oh, that's extension. That's the next page, right? All right, number 16 is another equation we have to solve, but this time they're exponential equations. So the log ones we turned into exponential. The exponential ones we turn into logs, remember? So we take the log of both sides, and since we turned it into logs, what can I do with the two exponents that are up there? Where can we put them? What was the rule with those exponents when we took the log of both sides? Can move them to the front, remember? So we get them out of the exponent level and put them on the main level. So we get x plus 1 times the log of 81 equals negative x plus 5 times the log of 1/9. Then what was the next step? moving one of the logs to the other side, right? I always took the one on the left over to the one on the right. So how do I move the log 81 over? Add, subtract, multiply, divide. Divide, right? This is multiplication here, right? So to move it over, I divide by log of 81. But if you wanted to divide by log of 1/9, move the one on the right to the left, you can, but I always go the one on the left to the right. That's just how I do it. So the log 81's cancel. All I have on the left is x plus 1. And in my calculator, oops, why did I put 1/9 over there? What should that be?
81.
Yeah, 81.
Calculator.
Sorry about that. But you guys caught that, right? Come on, it's kind of slow. Come on. Did it freeze? No, it didn't. All right, let's move some of that stuff. All right, so this should have been 81 here. What you do on one side, you gotta do to the other, right? So hit the log button, and you get that parenthesis. All right, so do 1/9, and then close it up. Divided by, hit your log button again, 81, close it up. So you get negative 0.5 or negative 1/2. I like to write negative 1/2. All right, so that's the problem now. All right, distribute the negative 1/2 and then solve for x. So from here, it should be pretty easy for you. Negative 1/2 times the negative x is positive 1/2 x. And negative 1/2 times 5 is negative 5/2. I'm going to take the 1/2 over to the x side. And I'm going to take the negative 1 over to the other side. Just doing 2 steps at once there to save a little time. So the 1's go away and the 1/2 x's go away. So negative 5/2 and a negative 2/2 is a negative 7/2. I just changed 1 to 2/2. And then 1 minus 1/2 is 1/2, right? So you can divide by 1/2, but what's easier? Multiply by its reciprocal. So I'm going to multiply by 2/1 to get x by itself. What happens to the 2's then? They cancel, right? So my answer is negative 7. Okay?
How did we get 7 over the 2?
Negative 5/2 minus 1. I changed 1 to halves. So this was like 1/1. So I multiplied by 2 both top and bottom to make it halves. So negative 5 minus 2 gives us negative 7/2. You can put that in your calculator too, you know. Fractions I like to put in parentheses on this calculator. All right, and then I hit math, enter twice for the fraction. Okay. All right, let's get the next one. 17 is just like 16, another one of these. So I'm going to say the x plus 2, I'm going to move to the front because I'm taking the log of 4 equals x times the log of 8. I'm moving the x, so I'm kind of putting it out front because I'm taking the log of both sides. So I did that first step right away when I wrote it down. You with me? I'm going to divide both sides by the log of 4. So this is just like the last one. And I guess x plus 2 on the left equals something x, whatever log of 8 divided by log of 4 is. So I think it's 1.5. Let me see. Log of 8 divided by log of 4. Yeah, 1.5. All right, so there's my problem now after I divided both sides by the log of 4. I'm gonna subtract the x over to this side, since that'll just give me a 2 on the left. What's 1.5 minus 1?
Half.
A half, right? And again, dividing by a half is like multiplying by 2. So the answer is 4.
That's introduction. Okay, good.
Okay. Again, if that's one of our multiple choice ones, you could look at your choices and then put it 4 to the 4 plus 2, 4 to the 6. Does that equal 8 to the 4th? Right? And if it does, you could just pick that choice of 4, right? So again, when it's multiple choice, you've got the choices. If it's an equation like we just had the last couple, you can just plug in and figure out which one's which, right? If you're stuck. All right, 18. Here's another one that we're solving. It's already a single log, so it's very similar to 15. We didn't have to do the turn it into a single log step. So x minus 2 equals what? Since the base is 4 this time instead of 10.
4/3.
4 to the third, yeah.
Yeah. 4/3.
Right, that's the base. All right. So 4 to the third is 64. And then add the 2, and your answer is 66. Okay. 19, we talked about this. It's subtraction. We're turning 2 logs into a single log. So what do I do with the 2 numbers? Since it was subtraction. All they want us to do is condense it. Okay? So the addition one we turn into multiplication, subtraction one we're going to turn into division. Right? So it's log base 5, same log, same base, and 125 over 5. Well, what is 125 divided by 5?
25.
Yeah, 25. Not equals, but. So we just condensed it to a single log, and that's all you had to do. You didn't have to actually find the answer to what that is. All of you know that answer is 2, though, right? But that's not what I asked you to do. I just wanted you to express it as a single log, and that's what we did. All right? So if that was addition here, I would have multiplied 125 times 5. That's all. Okay? All right, the last one is just putting in your calculator. Number 20 for today, last one for today. So we got log base 4 of 16 to the negative 5 power. Okay? I like to use my rule. Since it's a log, what can I do with that negative 5? I like to put that out front. Okay? There was a rule we had learned called the change of base formula that says I can put all this in my calculator. So it's negative 5 times log, and when you hit log, it gives you that parenthesis. So close it up. Remember, the base stays in the basement, right? So the log of 4, the base, stayed in the basement of our fraction. So if you put that in your calculator, that'll give you the answer, which would be negative 10. Negative 5 times 2. Okay? So that's all calculator there. All right? So that's the second 10. Any questions? You want to go back to look at anything that, because I kind of went fast towards the end to make sure we got the last couple in.
I'm good.
All right, so good job today. Y'all get a 5. Where?